Okay, so what are we ready for? I think problem 3, maybe? All right, and remember Mrs. Ford, because she's so nice and doesn't want to stress anybody. I'm going to give you the formulas, so I'll write them down up here at the top. Not going to go back through what all these letters stand for. We used this formula twice yesterday. That should be in your notes. We have not yet used hurt, so we'll see if we can find one of those today to use. Oh my goodness, here it is right off the bat. Number 3. How long will it take for a population of 450 geosites to double if their growth constant is 0.123? Now, this is not a money problem. Would you agree with me?
Yes.
This is a population growth problem, and this is our formula for continuous growth or population growth, or in big terms, any kind of natural growth. So if it's a nature type problem, a population of bacteria, a radioactive element, anything like that is going to use this formula. A stands for the same thing it stood for over here. Who remembers? What does A stand for? The end amount. So this is however much I end with. T stands for the same thing it stood for over there, which is the start amount. Now, this is our good friend E. That is not a variable. You're not going to plug anything in for it. That's E. R, you want to guess what that is? It's the growth rate. This is the growth rate. Now, in a money problem, we would call that the interest rate. But this isn't a money problem, so we just call it the growth rate. And T is time. Okay, so let's look at what we've been given in number 3 and let's plug in stuff. Where do you think the 450 is going to go?
P.
That's P. That's what I'm starting with. So this is going to be 450. There's my E right next to it. Their growth constant is 0.123. So that's the rate. Now it says, how long will it take? So do you think T is my variable? What's my A? 900. Somebody said it. Why is A 900? Double. I'm doubling. So doesn't it make sense that if I'm starting with 450, I would be ending with 900?
Yes.
All right, we saw some of these yesterday that look just like this. Anybody remember how to start? This is really important. Step 1, divide by 450. And what's going to happen when we divide by 450? 2 equals E to the 0.13t. Now what do I do? ln both sides. Since this has an E in it, let's ln it. And if I ln both sides, what really cool thing happens right here? It cancels. So I have ln 2 equals 0.123t. This cancels. So ln 2 equals 0.123t, which means t equals ln 2 over 0.123. So if you have your calculator today, it would be awesome if you got it out. ln 2, whoops, turn it on. ln 2, don't forget to close the parentheses, divided by 0.123. And I got 5.6353. Now what I can't tell from the problem is that days or years or minutes or what, I can't tell. So I'll just make one up. I'll say days. It doesn't tell me in the problem. So I don't know. Some unit of time, months, hours, who knows? What do you think? Is that okay? That's manageable. I don't think that's so bad. Let's try the bottom one then, number 4. How much do I need to deposit in an account paying 4% interest compounded continuously. Now that is a trick. Compounded continuously. Even though it's a money problem, if it says compounded continuously, we're using our PERT formula. The only time you will use PERT for money is if it says the word continuous in it. If the word continuous is in the problem, you're using PERT. All right, how much do I need to deposit? Paying 4% if I want to have $35,000 in 10 years. All right, tell me where to put what? 35,000 goes in right here for A, right?
There's no
P is what I'm looking for. There's E. E goes in all the time. 0.04 is my interest rate. Everybody got that? You're putting it in as a decimal. And T is 10. So I'm going to go ahead and multiply those together first. So I have 35,000 equals PE to 0.4. If I just multiply those two together, RT. What do you think? Robbie?
It's sort of like a wild guess, but like, would you do like raise 35000 to the 1 over?
That is an awesome guess. No, you don't do that. If this were the variable, that is exactly what I would do. But that's a really good guess and very impressive. But not the right thing to do in this problem because that's not a variable. Actually, it's easier than that. We're going to divide both sides by e to the 0.4. Now, some of you might be saying, well, wait a minute, why don't I use logarithms? Remember, logarithms are used when your variable is the exponent. If your variable is not an exponent, please don't use logarithms. It will make it harder. All right, so I'm going to type into my calculator P equals 35,000 divided by e to the 0.4. Marley?
Instead of dividing by e to the 0.4, can't you just type it in your calculator and divide by that number?
You mean type in e to the 0.4? And yeah, absolutely, it's the same thing. It'll save me a step if I type it in this way, but yeah, I'm going to get the same answer. So 35,000, whoops, I got some other buttons pressed. 35,000 divided by, now, I can't remember if we've ever gotten E on our calculator before. To get E, I want you to press second ln, and did that bring E up? With a little caret, 0.4 is your power. And see if you got 23,461.20. If you didn't, let's go through those steps again. Type 35,000 divided by second ln 0.4. And that's what you get, $23,461.20. How's come I didn't use logarithms on that problem? My variable was not an exponent, that's the key. Okay, we're going to skip number 5 and go to number 6. We'll come back and get 5. I think we'll have time. Well, let's go to number 6 because it's like one we've already done. Here we go, number 6. First thing you do, read the problem, and then decide which formula will be the best one to use. Which formula will be the best one to use? Paul?
PERT.
PERT. We're going to use PERT. We're on number 6. We're going to do PERT. tell me what to put where. John, do you have any idea what to do with any of those numbers? 193, 391, 0.222?
You start with 391.
What?
Is P 391?
Let's read it again. How long will it take for 193 to grow into or to become 391? Now, in my formula, John, A is what I end with. So how many am I hoping to end with? Yeah, so that's my 391. And then what do I do with my 193? It's P. It's what I'm starting with. And what do I do with the 0.222? Well, where does it go? Does it go in for R or T? It goes in for R, 0.222, and T is my variable. Now, what does it tell me about my strategy if T is my variable? I'm going to use logarithms, right? But not yet. What do I do first? Divide. So 391 over 193, and I don't know what that is, and I'm not worried about it. I have a calculator. Now what? This is the big step. What do I do now? Now I'm going to ln both sides. And over here I have ln this awful fraction. And what do I have over here? 0.222t? Remember, when you have an ln and an e back to back, they cancel. So then I'll take ln, that awful fraction, and I will simply divide it by 0.222. So let's see what we come up with. Those of you with calculators, it'd be great if you typed in with me. I got 3.1803. And again, did I put a time in there or not? Nope. So I might say this one is months. I am totally making that up. But I need some kind of label on it. All right, number 7. First thing you do after you read the problem is figure out what formula you're going to use. So what formula do you think we'll use for number 7? This one? We're compounding monthly. All right, so tell me what to put where. I don't know what A is. Isn't that what I'm looking for? How much I'll end up with? So 555. That's a 1. Okay, do I have an interest rate? 0.035. Over 12. Now let's stop right there. Why is that over 12? Monthly. N is how many times you're compounding. So my exponent is going to have another n in it, so it's 12. Oh, times 12? All right, let's stop right here. Make sure everybody's good with got stuff plugged in where it belongs. So I'm going to go ahead and make that a 144. Is that okay with everybody? Now, do I need logarithms? Heck no. I'm just going to plug this guy in. I'm going to plug it in. So see that guy right there? I'm just going to plug. I'm just going to type 1 plus 0.035 divided by 12 equals. So I just typed this in on my calculator. Everybody got it typed in that has a calculator? Now I'm going to raise it using my arrow button to the 144th power. And then what am I going to do? Times it by 555. And the answer is $844.17. Now, did anybody not get that? We'll go back through the steps if you didn't get that. 2 more problems and we're done. We're going to do 8 and 5. So here we go, number 8. What interest rate, compounded continuously, PERT, compounded continuously is PERT. So what interest rate will be required to end up with $1,000 after 3 years if $890 is deposited? 1,000 equals 890. E, don't put anything in for E. Easy. Oh, R, I don't know. But 3. Uh-oh, stop and look. Where's my variable? Exponent. So I know at some point I'm going to need logarithms, but not yet. What do I have to do first? Divide. So I'm going to have 1,000 divided by 890 equals E to the 3R. Now, if you want to, can you erase a 0 off both those?
Sure.
Yeah, they cancel, right? You don't have to do that. You're going to type it in anyway. Now, what do you do? ln. ln both sides. And the beautiful, beautiful thing is, what happens over here? Just 3R. So R ends up equaling ln 100 over 89 or 1,000 over 890 divided by 3. Oh, I messed that up. Did you get? That's not right.
I did.
Did you get 0.0388? Which, if you wanted to answer as a percentage, would be 3.88.
I divided the 3 after solving.
That's what I did too. I find the ln and then divide. This is what you got, right? Yeah. Yep. All right, one more and we're done. 5 is a little bit different. Which formula do you think we're going to use? Find the decay constant of an element. That's PERT. And it's PERT because PERT is used for anything natural. And this is like a nature problem. Okay? Now we need to think back. Samantha, is everything okay, Angel? Yeah. Okay. We got to think back to our chemistry class. What do we mean by half-life? What does that mean? Do you remember? Hannah, do you remember? Not a clue. Okay. Half-life, your chemistry teachers would not be proud, by the way, but I won't tell them. Half-life is the amount of time it takes for the element to lose half of its radioactive parts. So, in other words, you go from 10 down to 5, or you go from 8 to 4, or you go from 36 to 18. Half of it decays. So in this case, now be careful. I don't know how much I'm starting with. Does it tell me, Mrs. Ford, you're starting with 100 grams? No. I have no idea how much I'm starting with, but it doesn't matter. Whatever I start with, I am going to end with exactly half of it. So if we want to start with 100 grams, we can, and we're going to end up with 50. If you want to start with 40 grams and end up with 20, that's fine. If you want to start with 2 and end up with 1, that's fine. You'll see in a minute why it doesn't matter. The rate, I have no idea, but the time is 10.2 years. 10.2 is a time, not an amount. The amounts, starting and ending, you don't know. All you know is their relationship, half. Now, what's step 1 in this problem? Divide by 100. Now, what's going to happen when I divide by 100? I'm going to get 1/2 over here, right? Now, I want to show you something, kids. What if you said, I'm going to start with 40 grams and end up with 20? Then your formula would look like this, because you're starting with 40 and ending with 20. What's your first step? And what's going to happen when you divide? You're going to get 1/2. That's the key. So I don't care how much you start with, just end up with half of it. Okay? Now, I got this equation. What do I do at this point? ln both sides. And of course that goes away. So I have ln 0.5 equals 10.2r. So r equals ln 0.5 over 10.2. Now type that in and get ready for a shockaroozy.
Is it okay if it's
Well, we're going to talk about that. Negative 0.0680 basically. Which is like a negative 6.8% growth. Wait a second, what's going on here? It's decay. So of course its growth constant will be negative. It's losing, right? You would never want that to happen in a money problem, right? Because in a money problem, if that happened, it would mean your account was going down in value instead of going up. So we would never want that to happen. Yes, Deshanti.
Oh, sorry.
Oh, you're just stretching? Okay, great. All right, note sheets completed. So now what do? Let's get out our, oh, what did you say? Yes, good. Good. Let's get out our practice test. Yeah, I was afraid somebody would say, let's just leave, or something dumb like that, because we don't do that. All right, you got your practice test. Get them out. Come on. All right, so we'll just start with number 1. Oh my gosh, this has been a long time ago, but let's see if we remember it. This was the very first thing we talked about, and you all found it so incredibly easy. All right, let's take a look at equation number 1. Is it growth or decay? Growth. Good. Do you remember the rule? If the number in parentheses with the x thing, if it's more than 1, it's growth. If it's less than 1, it's decay. Super duper. So it's a growth. What is the percent of growth? 2%. Why is it 2%? Because it's 1.02. However much you're more than 1 is your growth. What is the initial value? 3. All right, there you go. Everybody's got a perfect test question. Marley, what you working on, babe?
I was just writing down homework.
Okay, well, let's wait and do that another time. All right, number 2. All right, this is a little bit harder. Number 2, we're going to write the exponential. Does anyone remember the general form? Like for a line, it's y equals mx plus b. What is the general form for an exponential? Do you remember? Y equals, bingo, a times b to the x. That's it. That's it. That's what we're shooting for. And you've been given 2 points. Does anybody remember how we proceed with our 2 points? We start with the one that has a 0. Please tell me this is ringing some bells. We start with the one that has the 0. This is your x and this is your y. So 2 equals a times b to the 0th. And then we remember that b to the 0th is just 1. So A works out to be 2. A is 2. This number's always A, isn't it?
Yes, it is.
So y equals 2b to the x is where we're at now. Y equals 2b to the x. Now what do?
18 equals 2.
Plug in our other point. Yes, Molly, good. 18 equals 2b squared.
Divide by 2.
Divide by 2, so 9 equals b squared.
Square root.
Square root, so b equals 3. But do not get so excited that you forget to write your answer. Your answer is y equals 2 times 3 to the x. Because A was 2 and B was 3. Remember, we are never, ever going to combine these. Right? Ever. I'll say that again. We are never going to combine those. All right, part 3. Oh boy, there's a lot of these. Let's see if we can remember any of them. A. 1 over 8 squared, which of course you'll write as 1 over 64. Everybody keeping up? I would like nothing better than a bunch of great tests this time around. All right, now what about B? Now be careful with B. What's that negative exponent going to do to this guy? Flip it. So it's going to make it 4 over 1 cubed, or 4 cubed. And 4 cubed is 64. So the answer to B is 64. C. Oh my goodness. 5. 5. The answer's 5. Why is the answer 5? Because when you have L and E back to back, they cancel. Every time. So the answer's 5. D, you had this on your quiz. Log base 4 of 16. You want these two numbers to match. So what are we going to do with the 16? We'll write it as 4 squared. And then what happens when these two match? So the answer is 2. Yeah, Marley?
Could you also set it equal to x? Because I got the same.
And translate it? 4 to the x equals 16? Absolutely. Absolutely, that will always work. Here's another quiz question. 27 to the negative 2/3. Step 1, don't get ahead of yourselves. 1 over 27 to the 2/3. What does that mean? So 1 over the cube root of 27 squared. The cube root of 27 is 3, squared is 9. 1 over 9. Kervin, you keep it up there? Good. F. Oh my. These are the hardest ones. All right.
Square it all.
These are stupid.
Don't say that. Okay, now you've got some options. One option you have, somebody said square everything, and that'll work. I prefer personally, and it makes absolutely no difference, but I prefer to kind of clean this up a little bit before I square. Keeps my numbers smaller. What I mean by that is, I've got x's over x's. Now what's going to happen here? You're going to cancel 3 of them out and have 1 left over on the bottom. Think about it. You got 3 on the top and 4 on the bottom, so you start canceling. You have 1 left on the bottom. Now how about this guy? What's going to happen to him? He's going to come down, but there's already 1 down there, so we'll have 5 of them down there. And gonna square that. Whole thing. So 2 squared, 3 squared, x squared. All right, now what's this one? Yes, ma'am, y to the 10th. That's exactly right. Okay, we're going to do G and then stop, and the reason we're going to do G is because you can do it without showing any work. What's the answer? 9. Those 2's cancel out, and the answer is 9. Nick, would you turn us off up there, please, and hand me the iPad? All right, you guys are awesome. We're a little bit ahead of the game.